Hello and welcome to the Fully Charged Show podcast. I'm Helen. When we talk about using less energy and less carbon, which we're doing a lot these days, which is a good thing, we're often thinking about the things that we do every day as humans. How do we move ourselves around? What do we eat? What do we package the things we buy? What do we buy? All of that stuff. But what about the energy and the carbon, the use of energy and carbon that's designed into the infrastructure that's all around us? So it's not energy efficiency or anything like that. It's actually the buildings and the infrastructure themselves. In this podcast, I'm talking to Maria Smith, who's the Director of Sustainability and Physics at Buro Happold. Maria started out as an architect, did an engineering degree, and now works in creating a more sustainable future, especially when it comes to those things like buildings that can be big problems hidden in plain sight. I'd never really thought about whether you could make a modern building without concrete, but apparently it is possible, and it might be a very good thing. And actually, maybe we could recycle buildings, which is quite a thought. But yeah, why not if you can? So maybe we don't have to build buildings the way that it's always been done, and this is an important part of the climate conversation. And so it's quite exciting to think about all the possibilities that opens up, all the different ways you could do it. So here is the conversation with Maria.
My Energy is putting the I back into British innovation. My Energy is putting the I back into inventing the future. My Energy is putting the I back into inspiring a nation. Recharging the world with green, smart energy. Charge your EV with your PV and more. Visit myenergy.com and help to spark the green revolution. My Energy, driving the charge to a greener future.
Maria, thank you very much for joining us. Now, you are an expert in an area that we don't hear very much about on Fully Charged. So start off by telling us a little bit about what you do.
So my name is Maria Smith and I work at Buro Happold, which is an engineering practice based in the UK, but then we also have offices in the US and China, India, the Middle East and around Europe. And we are engineering consultants, essentially. And the core of what we work on is buildings and the built environment. So from infrastructure and sort of cycling infrastructure and so on, but all the way down to like really small installations and specific pieces of structural engineering and so on. And we're interested in everything around the built environment and engineering.
Now, once you start to think about the built environment, it includes a lot of things, but it does seem to be when we talk about carbon use and being more sustainable, all that kind of thing, we tend to think about vehicles and more vehicles and electricity production. Those are the two big things in the room, but there's quite a lot of buildings around. So tell us a little bit about why the built environment is important when thinking about a sustainable future.
So the built environment is hugely important when we're thinking about creating a sustainable future, partly because most of us spend most of our time in buildings, so they're really, really important to human life.
Especially during lockdown.
Absolutely. But also because the built environment contributes about 40% of our carbon emissions globally. So that's huge. We have, that's including both operating buildings, so heating them, cooling them, and running them, but also constructing new buildings, creating building materials to refurbish and maintain existing buildings. The construction processes themselves often use a lot of machinery that's sort of running on fossil fuels still. So there's a huge amount of carbon emissions associated with the built environment. It's a really, really difficult problem to solve, and it's really, really important that we do.
And why do we not hear more about it? Because it does seem to be it's kind of the elephant in the room. Once you start talking about those kind of statistics, like 40% is a lot. Why are we not talking about this more?
Great question.
Well, you're obviously talking about it.
I talk about it all the time. But I don't know. I guess it's because it's very, very difficult. I mean, we talk a lot about housing, obviously. About half of what we build in the UK is housing. And we talk a lot about making our homes more energy efficient. partly because that just makes things cheaper and sort of makes our homes more affordable to run. And we do talk a lot about sort of, things like that reduce the carbon emissions and their sort of an energy efficiency with the operating of our buildings. But the thing that we don't talk about very much, and that we're needing to talk about more and more, is the embodied carbon in construction materials and in the buildings. So that's like the carbon that's emitted creating the building materials. So sort of your concrete, steel, timber, everything that goes into a building has some carbon has probably been emitted in creating those materials, and then the assembly of all of those materials into a building also emits more carbon, and that's a huge part of it. And basically over the last years we've focused so much on the operation of our buildings and making sure that sort of they're better and better. But then when you look at the whole life cycle of a building, because we've improved our operational emissions, the embodied emissions are now the thing that are sort of the huger elephant in the room.
Well, I guess it's hard to feel, because I guess once you're in a building, it's already there. So some of that's taken into account, and all you can do is change the operating. But, people are, there's building sites everywhere. Someone's building something. So this phrase embodied carbon is going to come up a lot, I think, in this podcast. So you gave us an overview there, but this is a life cycle thing. So let's pick, I don't know, say... I'm trying to think of a bit of a building, and I'm aware that you're an architect and I'm not, and so I don't know very much about bits of buildings, but so a concrete foundation, for example. Tell me about the embodied carbon of something like that.
So to create concrete, you have to go through a load of processes. You have to extract the raw materials, so that's going to emit carbon because the machinery that you're using in sort of mining the materials is probably diesel, and then you're going to have to sort of grind that down again. Carbon emissions associated with that. Concrete's a really thorny one because the process, the chemical process to create cement emits carbon in and of itself. But then still you've got to transport that. You've got to probably transport the raw materials to the concrete plant, then you've got to transport the concrete to the site, and then you've got to pour it, and then you've got to sort of do loads more works with it. So over that whole process, there have been loads and loads of stages where carbon has been emitted. But it's a whole life cycle. And an interesting thing about concrete is that actually once it's up as a building, it starts to take in some carbon, starts to sequester it. Now, being clear, it's not anywhere near as much as it was emitted in the first place to get it there. But it's an interesting thing to think about. Like, if we've got all this concrete there already, we want to make sure that we do maximise the sequestering potential there. But then, later, maybe the building is sort of reached the end of its useful life. You need to demolish it, take it apart. That process is also going to probably be emitting carbon because, again, you're using machinery and so on. Then you're transporting it again. So all of these different stages of a building production emit carbon, and we need to look at all of them. And I suppose that's one of the reasons that it becomes this huge 40% statistics, because it's so many different aspects of industry, so many different aspects of regulation touch it. And so it's a really big, thorny problem.
I think I looked up some stats before this, and I found something that concrete, just by itself, concrete is responsible for 5% of global carbon emissions. And I think aviation, which we talk about all the time, is somewhere around 2 or 3%. I can't quite remember, but it's a lot. So what do we do? I mean, one of the problems we have, I guess, is that people sort of need buildings. That's the way we set up our civilization. How much is it possible to do about I mean, because concrete sounds like a problem until you think about what would you do if you didn't have any concrete. How do you think about this?
I mean, I'm pro buildings. I think I'm all for the great indoors. But obviously, we have an existing built fabric. We have loads and loads of buildings. We have lots of building materials that are sitting in existing buildings already. So one thing that we might do that's kind of, already we're thinking about this in lots of industries, but just sort of throwing less away, right? Reducing our waste from building sites. I mean, the biggest impact, and I've forgotten the statistic right now, but the hugest proportion of waste that create is also construction waste. So if we can, rather than throw all of that building material away, if we can take that, deconstruct it carefully rather than just demolishing it, and reuse as much of those building materials as possible, then we can build the new buildings that we need largely out of those materials. So that's, one thing that we need to do. We also need to try to use our existing buildings more efficiently and more cleverly, honestly, like optimize those. You know, we did a really interesting project at Buro Happold for a hospital, and they came to us and they said, we need to build this massive new extension because we're inundated with patients. We're really, really busy. There's not enough space in this hospital. And we said, okay, hang on a minute. Let's just have a look at actually how do you use all of the spaces? And we did this really detailed study looking at how each of the spaces was used, how it was used at different times of the day. And by actually reconfiguring the way that the existing building was used, we said, you don't need an extension. You just need to change the way this building is used, and saved them like £3 million. They were very pleased.
And the developer wasn't. Whoever was built the building, someone wasn't happy.
Well, maybe this is why. Yeah.
Sounds very sensible.
If we could be like more sensible with the existing buildings that we have, and not throw so many of the existing building materials away, we've already gone sort of a long way to solving some of these problems, and still being, of course, pro-buildings.
Are you making me think of all the skips? There's always a massive skip next to a building site, isn't there?
Yeah. Those tubes that sort of come down off building sites and then like land in skips always fascinate me. It's like, what is going down there?
We should make them transparent, so then we'd all be able to see. It'd be brilliant.
Yeah, that's a good idea.
See what they're throwing away.
But yeah, of course, you know, we do still need to build new buildings. We need to make sure that we have safe and secure housing for everybody. So it's also important that we change the way that we do build those new buildings, and we build them out of lower carbon materials, that we make those materials, the existing materials that we have, lower carbon impact and so on. So it's basically, we have to intervene at every single stage of the supply chain and work together to reduce the impact.
So we'll get into some of the building materials in a minute, but how are builders on board with this? How much resistance do you meet in the world when you start talking about this kind of thing?
It's changed so much over the last couple of years. I think sort of around 2018, around when the IPCC report came out, and then, you know, there was just that huge like mainstreaming and everything coming through with the Extinction Rebellion. It changed the industry as well. Our industry, it really raised awareness. And I think, you know, by and large, most people care. Most people understand that this is a huge problem. But it's also just really challenging, you know, as in any industry, figuring out like, okay, but what can I do in my individual, you know, maybe I'm a bricklayer. What can I do if I'm a bricklayer? Or maybe I'm a cost planner. What can I do? You know, and we're having more and more conversations. And it's changed so much. It's really hopeful how much it has changed, and I think it will continue to change. But we've been seeing a lot the sort of regulations starting to shift a little bit, and you've seen things come out around things like the Future Home Standard and so on that are trying to shift regulation a little bit towards that direction. But actually the industry is moving faster than regulation at the moment, and the industry is trying to campaign for like regulate us more, regulate embodied carbon, like make us do things. Yeah, and that's really exciting to see. And like from across, you can see that there are lots of engineering companies and architecture practices and so on that have declared a climate emergency. There are developers that have made big statements about how they're going to reduce their carbon emissions, things like the Better Building Partnership, lots and lots of institutions. So there's a huge change across the industry in terms of declaring, but that's like step one, right? Like, yes, we recognise, we acknowledge there's a huge problem, we've got loads to do about it, but now it's like, okay, we've got to get into the weeds of this. We've actually got to change the way that we build, and this changes our processes, and it makes us all have to work harder to figure out we can't just kind of go on autopilot, we can't do business as usual anymore. And that's what we're in the thick of now, which is why my team's so busy.
All right, well, let's get to some of the culprits, because I get when the easiest way to think about at least some of this is just the stuff that goes into a building. And if you hang around a building site, not that I do very much of it, there's a lot of concrete and steel. So let's start with the concrete. So you've mentioned this already. So concrete, not good at the moment for carbon emissions. How do we make it less bad? I mean, do we just have to stop using concrete, or are there alternatives? Are there just better ways of using concrete itself?
So, I mean, concrete is problematic because the process of creating cement, the chemical process of creating cement, does release carbon dioxide in and of itself. So that's tricky. So But there are lots and lots of things that we can do to reduce the carbon impact of concrete. And so there's things like replacing a lot of the cement with things like GGBS, which is ground granulated blast furnace slag.
That's a great name. What does that mean?
It's a byproduct from the steel industry, essentially, but you can use it to replace a lot of the cement. And that means that the concrete takes a little bit longer to cure, but it's actually stronger and it's actually cheaper. So there are things like that we can do to reduce the impact, and there are different kinds of cement replacements that you can use because it's the cement that's the real problem there. So the things like that, there are things around design so that you can make sure that your structural designs especially are much more optimized. So rather than sort of just putting in massive flat slabs everywhere and so on, you can do things like you can tension them with steel so that you have a much thinner slabs. You can just be more careful with your design. So like look at the actual loadings that you need. You know, a lot of our office buildings are designed as if they were sort of filing cabinets, cheek by jowl, all the way across the floor. Like we don't live like that, we don't work like that anymore, so we can actually think much more carefully about what realistic loadings do we need. Let's not overstructure buildings.
You know what's terrifying about that though is that if for any reason, so everyone's got their tablets and very small laptops, but if for any reason in 20 years time the filing cabinets came back, the buildings would all fall down. I mean, I thought about that as a risk.
But I think it'd be a really interesting kind of dystopian future, like oh no, filing cabinets are back and it's causing the end of days. I mean, obviously we've got to be sensible, and we have to think about, because you know, future-proofing the buildings, we do not want to be creating buildings that we have to demolish, so we have to be sensible about it. But one thing that I think is quite smart is, for example, like creating the columns so that they could take more load in the future. So if you need to build additional stories above later, that's fine, you've thought about that. But the floor slabs themselves that are unlikely to go beyond a sort of certain point, and doing a lot more to monitor them as well, like actually put sort of strain gauges in and things, so you're actually figuring out how well the buildings are being used. And I know that, you know, some structural engineers are working very closely with especially estates that have like long-term, you know, custodianship over their buildings. Will think much more about these sorts of things, thinking about the way that we're stewarding our buildings and looking after them. So there's a bunch of things that we can do to sort of reduce the impact of the carbon of the concrete, reduce the concrete a bit. But yeah, at the end of the day, concrete is problematic. Now, that I should say, there's loads of research and work being done on creating zero concrete, and you know, there are precast products, for example, where you can actually use carbon dioxide to cure the concrete in and of itself. So then you get these stone pieces that have sequestered carbon. Brilliant! It's doing, you know, the absolute thing that we wanted to do, and you could build with those. And there are all sort of things looking at how to make concrete zero carbon or even carbon positive. Some of those are relying on sort of closed loop carbon capture technology. And if that works, then great. But I think that the thing that a lot of us are sort of saying is like, fantastic, if that works, then we can build with concrete with wild, free abandon again. But in the meantime, every time we don't want the
1970s back. Brutalist architecture. Okay, maybe not. I'm not. You know, I think
well,
enough of that.
Architects love the brutalist.
Yeah, no, the rest of us not so keen.
Well, maybe that's good. Maybe that's for the best. But we can use more concrete in the future, and we can build a fantastic brutalist utopia if that's what we want to do. That is our choice for the future. But in the meantime, we need to reduce the amount of concrete we're using until such time as that is possible. And so we have to use timber more, we have to use earth more, we have to use stone, we have to use steel, 100% recycled content, of course. We have to use these other structural, especially materials, more, so that we can reduce the concrete, and then later we'll be able to play with those beautiful concrete sculptural forms, because it's a fantastic material. I get it, I understand why people love it. It's like, you can do the Sydney Opera House with concrete, it's fantastic. You can't do that with a lot of other materials, but we have to think about the kind of aesthetics that you can achieve with these other materials. And that's a really interesting and exciting design challenge as well. And so the more that we see people focusing on that now, then it's yeah.
So is concrete replaceable? If you think about, sort of tall buildings, because homes, I guess you can see if it's 1 or 2 or 3 floors, it's a bit easier. But we associate concrete with quite tall buildings, whether they're offices or apartment blocks or that kind of thing. Can you build something like that without concrete foundations, without concrete, in the middle? How would you do that?
So, I mean, tall buildings, you can build tall buildings in timber and steel, and there are examples of them all over the world. And sort of, I think the thing is with tall buildings is because beyond a certain height, and I've heard people call it the Goldilocks height, which I really like, because tall buildings become more and more and more carbon intensive in all sorts of ways in terms of the efficiencies, their energy efficiency and things as well as the embodied carbon. So I think, building very, very, very tall buildings needs to be the exception. There needs to be a really good reason to do that. By and large, we should not be building huge tall buildings.
How high is the Goldilocks height? I'm fascinated by that.
I think it's around the kind of 5 to 7 story.
Oh, so it's not very high. It's not very. I mean,
huge,
on the scale
no.
of if you walk around a city, you'd see quite a lot of buildings. The taller ones.
Depends on the city. Go to Amsterdam. But yeah. But you mentioned foundations. Now, foundations are they're the trickiest.
Quite important.
Proposition of all. They are very important. But they're one of the hardest things to address, and with them basements as well. Basements, absolute disaster. We should not be building any basements that we don't absolutely need.
What's wrong?
There again, you're putting.
What's wrong with the basement?
You're putting loads and loads of concrete in the ground, not only to sort of stabilize the rest of the building, but actually, creating encased spaces. And we're often getting stories and stories of basements, filling them with car parks, and so then just compounding this other problem that we have. So and not to mention the kind of the implications on flooding, and it's just so when we calculate the embodied carbon of buildings, quite often you'll do that at a kind of design stage still. You'll be looking at different options, and there's an option with a basement and there's an option without a basement, and it's dramatic difference. So so basements, not a big fan. Obviously, there are some occasions where they're important. Not being completely extreme about everything, but
special people are allowed basements.
Some special people. No, but this is the thing, right? How do we start to think about? It starts to get into the language of rationing, right? Okay, so for some, who's allowed to create concrete foundation? Maybe somebody building a wind turbine is allowed to have a concrete foundation. Maybe that's a good use of our minimal quota of concrete. But maybe the person who's building a 2-story house that's only using a concrete foundation because that's just normal.
Easy. Yeah.
Maybe they ought to be thinking about other ways of stabilizing the earth. There's one of the fun things. So foundations. The big reason that we build foundations is to reduce settlement. So essentially that the buildings aren't sort of
wobbling, sinking.
Well, sinking was the word I was going to use, but slowly sinking into the ground. And obviously we see lots and lots of old buildings, they didn't have foundations, they had really minimal foundations, and they have sunk a little bit into the ground. That's okay, we call it characterful. But you also, obviously, they often will sink slightly more at one side or something like that. So then you have to create a building that can accommodate a bit of movement. And so things like timber frames that can be really good at accommodating that movement, whereas other things might be more brittle and might find that more challenging. Or the certain kinds of window systems and so on, they'll need to not deflect more than a certain amount, or the structure to not deflect more than a certain amount, otherwise they're going to start cracking. But if we can detail and design things so that actually they can accommodate a bit more movement, you can massively reduce your foundations, and depending on the kind of grounds that you're on, you can do things you can add lime to certain kinds of. It depends on the soils that you've got, but you can do things like add lime, and that actually firms up the ground much more, and then you can hugely reduce your foundations. And that kind of technology that's being used today, in wind turbines even, you still have some concrete foundations, but you can hugely reduce them. And I was speaking to one of my colleagues today about who's in our ground engineering team, and saying, so what percentage of projects are you having this conversation about, like reducing the concrete in the foundation? And she said, it's like, well, from sort of 2 years ago, it was sort of maybe 0 to 5% of projects. And now it's like 50% of projects. People are really thinking about, like, can I use, and another really fun one that I like is these vibro stone columns. So you get granulated like stone, it can be old concrete or something, and you pack it down into the ground.
Is it granulated? Kind of pins. What's granulated?
No, granulated.
I was excited. I thought it was a new word there.
Granulate. I was very excited. No. But you're compacting the earth by like forcing the
right.
Because you're vibrating the stone down into the ground and things like that. That are just reinforcing the earth. But anyway, yeah, just to show how much things have changed and how much clients have changed and builders have changed thinking about it over the last, to go from almost nothing to pretty much like 50% of projects are talking about like, well, what other things can we do to stabilize the earth and reduce that sort of need for foundations and reduce the need for sort of settlement and so on.
Sounds like you kind of want a sort of slightly softer, more wobbly built environment, something that's, I hesitate to use the word organic, but a bit softer around the edges, a bit less, here's a big lump of stuff that can't move. Are these other things, do they have other I mean, if they are better overall, is it just that we've only just worked them out, or are they more expensive or more difficult, or is it just, it's equivalent, it's just a different way of doing it?
The biggest problem in the construction industry is that we do things the way we've done things for the last couple of decades, right? Not the way we've always done things, absolutely not, because a lot of traditional building techniques with kind of natural materials and so on are actually brilliant. But we've got this like recent legacy of modernism and modern kind of aesthetics and the contemporary construction industry. So we do things that way because that's the way we've done things. So that's how we're set up to do them. So that's the most, it's the easiest to find the builder that can do that. It's the most sort of cost effective and so on. And it's that's our big challenge, really. It's not that we don't have really great technologies. I mean, obviously, research and development is important for the like cutting edge, but we've got a lot of the technologies that we need to already make an enormous difference. It's just really, really difficult to sort of scale that up enough because we do things the way we've been doing things. It's really
there's
frustrating.
efficiencies involved in only needing one type of machine or whatever, I guess. So how about let's move on down the materials. So steel also comes up, and steel gets. It's quite interesting because just the way that we've historically produced steel involves smelting it, and it involves coal still a lot of the time, coking coal, I think. And so steel's obviously, it's got the thing that makes it steel and not iron is it's got a bit of carbon in it. So there's obviously a bit of carbon. There's also a lot of heat. So how does steel work in the green building materials world?
So steel's difficult because, steel's very variable. You can get really good steel and you can get not so good steel. Like you've got steel that's been made from 100% virgin materials with through burning coal, obviously that's going to be hugely problematic. But then you can get, and this is true with other metals as well, but for example, aluminium might be another one, really, really tricky. But if you start increasing the recycled content to ideally 100% recycled content. I think in the UK we export more steel scrap than we import virgin steel. So
that's mad, isn't it?
There's something that we've got to do there. So if you can increase the amount of recycled content, and then if also you can use different power sources to actually create the steel, then you're onto a winner. And steel is easier than concrete because the technology is already there, it's already possible. It's just that thing of scaling it up, and depending on where you are, if you're sort of somewhere where you've got brilliant hydroelectric capabilities, then maybe you can make your kind of hydro aluminium, steel and so on. But there are different ways of doing it. But that's a problem that, again, we've got the technology, it's just a case of scaling it up.
And the job that steel does in a building, which is, it's kind of a bit flexible, it's got both tensile and compressive strength, it can bend a bit. Is there another material that could do that? Or is it pretty much you just need to make your steel better? You mentioned aluminium there. Never thought of aluminium being particularly strong. Maybe.
No, I mean, aluminium isn't so much for superstructures like that. It's, there's a lot of aluminium in buildings, though, like window frames and door handles and like lots of smaller things. I mean, timber is great in compressive strength and in tension and brilliant in bending, and it's a fantastic material, you know. So there's a huge movement to try and use more timber, but then there's also a lot of resistance, and there's a lot of obviously different.
I thought we'd run out of trees. I thought one of the reasons that everyone started using other things was that we sort of run out of trees. You know, if you look back to the, I don't know how, a few centuries back in Britain, and the whole place was forested, and then people just kept cutting the trees down. Have we got enough? Let's move on to the timber then. So have we got, could we use more wood? I mean, I assume so big. Obviously, if you want to make structural things, it's good if it's a whole tree or bigger bits of tree rather than smaller bits of tree. So that means you need big trees, which means they have to have grown for a while. We're not a patient species. What could we use? I mean,
maybe we just need to be a more patient species.
Solution to all these problems. More patient, happy with a slightly softer building. But is wood a sort of legitimate today, with the number of trees and forests being chopped down and all of those concerns? Is it a reasonable alternative?
It absolutely
today?
is. Obviously, we shouldn't go out with an axe and wild abandon and just cut down all the trees. And absolutely increasing forest cover is also really, really important. And it's a case of having, it just sounds like, I can barely even say it, but sustainable forestry. I mean, it's difficult to get that right. It's difficult to assure that you're actually getting that right. But and like you say, it's really important that you use the whole tree, that you're not just sort of using a small part of the tree and then actually the rest of it, you're just letting that root ball rot into the ground and then emitting more carbon, or you're just burning all the little branches and so on. And then, you have to think of, again, the whole life cycle of that tree. But a tree sequestering all that carbon over the first kind of 20, 30 years of its life, after which point the amount of carbon that it's going to sequester is going to slow down. So actually taking that and storing that in a building is a really good way of storing carbon from the atmosphere.
As long as you don't have a house fire, then it's fine. So as long as your building doesn't burn down.
Well, no, okay, but fire is important because there's understandably a lot of concern around fire and timber. But I just, it is absolutely possible to design fire-safe timber buildings. It's absolutely possible. And we do it all the time. And I think we just need to have really clear and strong regulations around that. We need to make sure that the fire-safe designs are actually being built to the fire-safe designs and making sure that quality is there. It's absolutely possible. But yes, for all sorts of reasons. Not least the carbon emissions associated with the fire and building. That's really important as well. But I think, this thing about there aren't enough trees left and so on. I think it's no one solution. It's not like we can just do everything that we're doing currently the same, except for we'll swap out everything with timber. The materials are really important. It's good that we're talking about them, and it's good that we're looking at them at that kind of, looking at the industry at that kind of granular level. But it's also really important that we think about, policies, for example, around vacant buildings, or policies around second homes, or policies around being able to share spaces much more and not having certain spaces that are only accessible to a privileged few, whereas lots of other people, we have to think about a whole built environment much more carefully, much more holistically, and make sure that we all have access to it in a fair way. So that we don't just have to rely on building more and more and more and more and more and more stuff, whether that's housing or whatever. It's actually about sharing all of those resources that we have, at a national, but also at an international level. So it's a whole systemic thing.
You want revolution, as always.
Well, yeah.
So are there examples of buildings? Because I guess one of the things, so I think a lot of the problems we have in asking about sustainable world, asking questions about it, is that overall, the point of almost all of our technology for the past, forever, has been to hide what's going on. And it wasn't necessarily sort of, malicious. It's just that it's almost like magic if a beautiful thing appears and you don't have to know how it was made. And there's been this, like, you know, we hide our electrical cables in the walls, we hide our sewage pipes. Like, who has actually ever seen a real sewage pipe other than when a hole was dug in the ground because one had gone wrong? Like, we hide it all. And buildings, it feels like they're kind of hiding in plain sight. Are there any really good buildings that, you know, we can look at next time we go past them, where you can say, actually, this one hiding in plain sight, this one was done differently?
I think probably like the best building that everyone's going to see is like a recently refurbished building. But I want to pick up on the thing that you said about hiding things. So I think there's something in there that's really important. So hang on, I'll come back to that. But the way that we've designed buildings in the past, hiding all of that stuff, means that they're really difficult to repair. And it's the same conversation we have around like lots of different kinds of products that, you know, you lots and lots of electronic equipment, for example, you know, you can't easily repair it, so you have to chuck away the whole thing. And buildings are the same. Like we need to shift to buildings that are like, it's really obvious. Like lots of stuff in buildings is really simple, right? Like a lot of people could repair their own homes much more easily if a lot more stuff was exposed and on display and so on. So we have to think about the way that we design things to be repaired, design things to be like maintained on and on. Like, and there's this examples of, for example, different kinds of earth architecture, like really, really traditional earth architecture, where because they're not stabilized with cement, the earth will sort of gradually degrade in the weather and so on. And so every year you would go and you would like replaster them on the outside, these buildings, all different kinds of buildings. And because we've been designing things to be just like finished, and so you don't ever have to maintain it, so you just hide everything away and it's just in this perfect like static state, that's part of the problem. And that aesthetic and that drive to create something that is finished and doesn't need that like ongoing care. But that's really dumb. Like, you don't look at your baby for 5 minutes in the morning, give it a good check over, still alive, and then not look at it until the next day, right? That's not what
I shouldn't laugh, because you would get told off if it's that is very sad that some people probably do that, but it is definitely not norm.
All right, well, maybe a less dark example is like, you don't do one really, really crazy workout on the 1st of January and then do nothing for the rest of the year and then expect your body to be in like peak physical condition, right? Like, you have to do little things all the time. And we don't think of our built environment in that way. We think of it as like a massive kind of construction project and then it's done and you can just sit back and enjoy it forever. And we need to have a much more sort of, I guess, interactive and like caring relationship with our buildings. And not hiding all of the stuff would be a really important part of that.
You've made me think, so I've never really thought about this in this context, but you know, I work at sea on ships quite a bit, and it is very obvious when you're on a ship that they are always maintaining something. Like basically while you're at sea, it's not like you go into port and then everyone does all the maintenance. Like while you're out at sea, they are painting things, maintaining things, fixing things, lubricating things. Like it's an ongoing, and that's what the crew is doing. Mostly they're not driving the ship. And I'd never thought about the fact that we do that for a ship, but we don't do that for a building. And in the case of a ship, it's because it's so expensive. It's such a big thing. It would take like port time is expensive. It's expensive to have a ship doing nothing. So if you can sort of be doing it along the way, why don't you? So we do it with ships. Maybe we should do it with buildings. Yeah,
I mean, obviously we do it to an extent, but we could do it much, 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 much more, and therefore we would the longevity of our buildings would go on for much longer, and so that we wouldn't need to demolish them and bring a new one. Which is why it's like the sort of the example of a really good project is probably something that's recently been refurbished, maybe it's changed use, maybe it hasn't, but it's sort of something where the energy efficiency has been improved and the livability of that building has been improved, but it's using an existing structure, and that does huge amounts to reduce the embodied carbon, because like that all that built fabric was already there, so you're just reusing it. And actually that's a really important part of the foundations question as well. Like, there are loads of foundations in the ground, we can build on those existing foundations, we just leave them there, keep building a different one, they'll last for much, much longer than any individual building. So we don't need to worry so much. There's loads of foundations.
Didn't they do that? Is it Edinburgh or somewhere where they just kind of built houses on top of houses, and there's parts where you can sort of, people have found their way down. Or maybe it's a sci-fi novel that I'm mixing up with reality.
Sounds great. But I mean, reusing foundations when you build a new building is not unusual, but it's not as usual, I suppose, as it could be.
And how about, the rest of the... Oh, and glass. We haven't talked about glass. So that's the other thing we hear. I mean, there's starting to be buildings now which have a lot of glass on the outside. Is this a good thing or not? Why do? Because I guess glass and steel, there's a type of building which it looks very glass and steel. How do we feel about glass?
Well, I mean, I think the biggest thing about glass really is not so much about the embodied carbon. It's more about the operational carbon. So how energy efficient is that going to be? How much are you going to have to cool the building because it's overheating, and how much you're going to have to heat the building because the U values and the amount of the thermal efficiency of the envelope of the building. So it's more about that, and there's a lot that you can do with things like, to prevent overheating, with things like thinking about the orientation, thinking about where your windows, where your fenestration is, and the industry's pretty good on the whole now, like at modelling that. We have really good, like even using sort of machine learning and things to sort of figure out, these really big, complicated thousands of home situations to sort of orientate things so that you're minimising your overheating and so on, and making sure that you kind of got maximum views and things. It's going to look like windows. It's not going to look like sort of fully glazed buildings in that sense. But actually, I was really impressed. There's a building going up in Shoreditch that's a timber frame, and then it's completely clad in glass, and then there are louvers, so screening and shielding the interior from certain places, from the right angles, and the embodied carbon of that is really, really low. And so long as that combination of thinking about the whole life cycle, as long as that combination is taken into account, and we consider, when we're doing that design, we look at the whole life cycle, then you can. So it's not a definite no to glass buildings. In short, it's a bit more complicated than that on that one.
And how about just come back to this idea of the built environment? Because there are, I don't know how wide the envelope of that term stretches, but if I look outside any window of any building I've been in, there are roads and pavements and bridges, and how about all of that? Like, do we need to worry about? I mean, obviously that causes problems with rain runoff, and sort of it makes floods and things more likely. What about that kind of built environment? What do we do about that?
Yeah, so to be fair to buildings, that 40% that I said earlier on does include infrastructure. So it includes our sort of roads and railways and so on, because that's part of the built environment as well. And yeah, we like to have our sticky mitts on everything. And we absolutely do have to worry about that. And there it's complicated, because obviously that thing around that you were mentioning at the beginning about vehicles, which vehicles we're going to have, do we really want to have roads, do we want to have public transport, that becomes the operational concern, and then the embodied concern is still there. And then the problem with concrete is huge as well. And when you start to think about the kind of infrastructure that includes things like flood defences, or managing earthworks and things like that. And so what we're looking at a lot more now, and this sort of thing that's become a buzzword, nature-based solutions. So thinking about how much can we manage things like, especially water management, and soil and earth works and so on like that. How much more can we use things like trees and marshlands and so on to mediate these things, so we can dramatically reduce the amount of concrete in there. But yeah, I mean, infrastructure is a huge issue. I suppose one of the really good things about infrastructure is that it's a lot of it is procured by central government. And so one of the things that a lot of us are, in terms of this point of like campaigning for, where the industry is and where legislation is, and wanting to campaign more strongly, is that if the procurement of those works can require certain levels of sustainability, considering embodied carbon and things like that, that can have a really big knock-on effect to the built environment. as a whole, and all the kind of the private the private aspects of it as well, and the more commercial aspects. So it's a really important like part of unlocking the overall problem, because of the scale of things as well. Like, you know, if you changed, and I think HS2 did do this actually, that they required the concrete specification to be, it was a percentage of cement replacement that they required kind of as a minimum, and that really shifted things. Like in the industry, like, oh yeah, okay, but they can do that, so we can do that.
And then you've demonstrated that it works.
Yeah,
and you've
exactly.
got the equipment to do it, and some big project has already set it up, so you just carry on.
It's enough for a market shift, right? So yeah, infrastructure, a big part of the problem, but also a big part of the solution, I think, because of the scale of it and the way that it's organised as well.
So if governments go into their infrastructure projects making requirements, they basically set the tone for everything else, and there's a huge knock-on effect afterwards.
Yes, please, if you could arrange that.
Yeah. I'll see what the fully charged magic wand can do. So when it comes, most of us are just kind of people wandering in and out of buildings when we're allowed to, and sort of getting on,
with our masks on.
getting on with our normal lives. How much of this, what can we do about it? I mean, is there anything that if you own a house, or you're renting, you're living in a house, is there anything you can do about any of these things, or is this all just big developers and big important people that have to worry about it?
So there are things that you can do in your home. It depends on the building that you live in, but maybe you can do things around making sure that your home is as insulated as it possibly can be. Simple things like making sure you've got loft insulation and things
but
like that.
But if you're building an extension,
do it.
If you're building an extension, for example, something where you are actually building a little bit of something.
Yeah. So I mean, I think most people in the industry now are on board with this idea around worrying about embodied carbon. So you can talk to your builders, your architects, your design teams about embodied carbon. You can be looking to use, if you're building an extension out of bricks, for example, use reclaimed bricks, because then those bricks have already been made and you don't need to have the embodied carbon associated with them. You can use the more materials that you reclaim in order to build from, then the better. So you'll be able to do things like that. You can use timber, as we mentioned, brilliant for domestic sort of scale, and I've done some lovely timber extensions. Works beautifully. And then, I think there's a point around our role as citizens. So every planning application that goes forward is open to public consultation. You can get involved in commenting on planning applications that are happening in your area. You can, depending on how active you want to be, but you can ask those questions at planning committees. You can inquire about the embodied carbon, or just about the, point out to the local authority if they have declared a climate emergency, which many of them have now, saying, okay, so you've declared a climate emergency. Is this building appropriate given that? Do you want... and some of them will be and some of them won't. But I think we can exercise more of our kind of collective power as citizens to make a difference as well. And to be honest, there'll be people on the design team that will be so happy to hear that. It's like, yes, they asked, and now we're going to have to do it. Brilliant, So
make their day.
Go for it, do it. Yeah, go on, make my building more sustainable.
So two more questions to finish off. So first of all, what is, you spend your time looking at all of this stuff, thinking about all of this stuff. What's the lowest hanging fruit that it's frustrating we're not doing already? What's the thing where you get up in the morning and go, why aren't we just doing that? Is there one thing that you would pick up?
So
you're not allowed to say all
one
of it.
thing. No, I'll pick something. I mean, I think one thing is just actually calculating the carbon. We have tools now, we have spreadsheets. The industry is upskilled so much, so we can calculate the whole life carbon of a project. We should be doing that at the earliest possible stage. Do it at the beginning, set a target, and when you're looking at different design options, when we're looking at different design options, we should be always factoring in, of course you've got to factor in cost and all sorts of brief points and things like that, but be factoring in carbon, because the easiest time to make those carbon reductions is right at the beginning of the project. So do that. If we do that right at the beginning of the project, then it's easy to make those changes then. And I think it's changing really quickly actually, but it was, from a couple of years ago, we're just not calculating the whole embodied the whole life carbon at all, to calculating it maybe towards the end, or just to know what it is. But now it's much more calculating it early stages, and that's what best practice is. And I think if everybody was doing that, because once you're confronted with it, it's like, well, shall we have 1,000 kilograms of carbon dioxide per square meter, or shall we have 300? And that's what that difference looks like on the plan. That's what you can see. Then I think we're just going to it's going to be much more. It's going to be much easier to make the right decision.
And then one final question, and this can include the hard stuff. If you were monarch of the world for a day, and you could invent a rule, so not just it could include hard stuff as well as easy stuff, I guess. You want to make the built environment less carbon intensive in some way. What would your rule be? Is there something where you go, I would make everyone do this, apart from the carbon calculation, because that's a low hanging fruit one? Is there one thing you'd pick on?
Yeah, it's probably a bit nerdy.
That's all right. We'll live with that. Go on. Share it with us.
No, but like policy nerdy, because I think, if I was monarch of the world for a day and I could do one thing, it would be around every country having to report their emissions on a consumption basis. So on the basis of what they actually consume within the nation's border. We currently do it on a territorial basis, so it's only what we actually produce. And this is really, really relevant to embodied carbon, because and the reason that we're not regulating embodied carbon is because under the current protocols, it's not our problem, because if it was emitted somewhere else, if you created that steel in India and then transported it to the UK and then used it in a building in the UK, the emissions associated with that steel, India's problem, not the UK's problem. That's not right. Our carbon footprint would be almost 50% bigger again in the UK, whereas I was looking at Kazakhstan, just as a random example, 25% lower. And that would just change everything. It would change the way that we thought about embodied carbon in the built environment, but also embodied carbon in cars, in trains. Like a lot of these sustainable in solar PV cells, a lot of these sustainable solutions have an embodied carbon cost, and we're not factoring that in enough. And I think one of the really core reasons behind this is because at our national level, we just don't think about our embodied emissions. So if you could arrange that would be great. I think it would just change mindsets completely.
Stop making it somebody else's problem. Which is the solution really to all of this, isn't it? It's our problem, not somebody else's problem. I don't think so. I'm sure the fully charged audience can get going on that. Brilliant. Well, thank you very much. It's been a pleasure to talk to you.
Well, I hope you enjoyed listening to all of that. It is the sort of thing that completely changes the way that you see a city. Just the thought of standing on the city street and actually looking at all the buildings, all that concrete, all that stuff has to come from somewhere, and it has to go somewhere. I really like the idea of recycling buildings. So I like the freedom. Buildings last for so long, we sort of assume that they're just always there, and for some reason that means we have to make them like this. And so the game of making them with less concrete and steel, all that kind of stuff, that sounds really interesting. So I am very keen to see what the architects of the future come up with some more sustainable materials. So thank you to Maria for sharing all of that with us. If you've liked this and you'd like to support us, there's all the normal subscribey things. You can support us on Patreon and subscribe to the podcast, and there's the website fullycharged.show, which I still can't say after all these months. But that's it for today. So if you have been, thank you for listening.